Hi, I'm Dr. Chris Creighton, and we're going to be talking about graphing exponential functions. And to wrap this up, why do we have these restrictions with a being positive and not 1? Well, first, let's do this in the two cases. So the first case, a is greater than 1. Why does that have to be? So like, for instance, what if I picked a is equal to negative 2? So let's just say we have f of x is equal to negative 2 to the x. And then we just go like, okay, let's just start picking numbers to plug in. So I'm going to pick f of 1/2. That's a completely reasonable thing to pick. So this is negative 2 to the 1/2 power, which is equal to the square root of negative 2, which is not real. That's our issue. In fact, it's complex. So in order to avoid that, we specify that a has to be a positive number. We don't want complex. In fact, there's other issues that can pop up too. So don't want complex numbers, depending on the choice of inputs. Some inputs work. So like if I plugged in like 1 or something like that, f of x of 1 is equal to negative 2. That's a completely valid input, but this one here, you essentially toss out anything that will have an even denominator. So all fractions with even denominators. And for the second one, why can't it be 1? That one's a little bit funny, because if I choose it, f of x is equal to 1 to the x. Let's just see what happens. So like f of 0 is equal to 1 to the 0, well that's 1. F of 1/2, well that's equal to 1/2, 1 to the 1/2, which is 1. F of like negative 3, well that's 1 to the negative 3, well that's 1. So if I chose the base being 1 here, what we'll see is that we don't want the function f of x is just equal to 1. 1 to any power is 1. This is a constant function, in that it doesn't change value. No matter what you plug in, you'll get 1. And so we want to avoid this, so we also specify that a is not 1. This allows us to say if a is between 0 and 1, it's a decreasing function, and that goes down as you go left to right, or if a is bigger than 1, this thing goes up. And it hits the constant function, because if it goes from going down to going up, then it'll eventually have to be like not going down nor up, hence this constant function. I'm going to wrap up with just an example of exactly what I mean by like where that constant function comes from. So I'm going to graph a handful of these. So I'm going to graph f of x is equal to 2 to the x, f of x is equal to 3 to the x, and then in a different colors, f of x is equal to 1/2 to the x, and then f of x is equal to 1/3 to the x. I'm going to do these a little bit quicker. So 2 to the x, so we have 0, 2, 4. So this one looks like this. It's like the best I can do. 3 to the x, it still crosses there, but at 1 we're now at 3, and at 2 we're all the way up at 9. So this thing like skyrockets, so like we're all the way up here. It's not the greatest function. And it comes down here and it slides along still with that horizontal asymptote. And then the other two, 1/2 to the x, you may notice is that there's a mirroring going on here. So at negative 1, we're up here at 2, there, and then at 1, we're at 1/2. So this thing slides down like this. And it goes up. Again, not my greatest graph. And then so for this one, it crosses here and comes down to 1/3. So this thing comes through like this. Color coding these things. And so if I keep putting in more and more fractions, like for instance, another example of one could be f of x is equal to 10 to the x. What this one does is that this thing skyrockets upwards much faster. So like this one would look like, okay, at 1 we're all the way up at 10, so this thing goes up like this, and then slides down like that. And like exponentially, it's really, really fast. But if I plug in things getting closer and closer to 1, so like f of x is equal to 1.1 to the x or something like that, what you'll start to see here is that this thing like starts to level out. So like this thing may go like this. Comes in much slower. It's not the greatest. Likewise, on the other side, if I do like f of x is equal to 0.9 to the x, put parentheses there, you'll see that mirroring happening where it comes in like this. Just do this one in yellow as well. And so these things start to flatten out. So you flatten out the closer you get to the 1. And so once this thing like it becomes 1, this thing just turns into the horizontal line. And that's where that horizontal a cannot be 1 comes in. So that is like the horizontal line here at 1. So this one corresponds to like, okay, this thing flattens out. This one flattens out. And so once you start choosing things like 0.99, 0.99999, no matter what values you plug in, this thing will eventually get big, but the rate it gets big is really, really slow. And so once you hit that threshold of 1, that's where it goes from increasing to decreasing. So like, for instance, that one goes up, this one comes down. So this thing is where it flips.